All right. So hope you guys can hear me loud and clear. So this is part 3, kind of a redo of the keyboard. We have some changes today and I'll be redoing some of the stuff. So what we have today that is different from last time, we have a acrylic case made for ErgoCape. This is the acrylic case, clear acrylic case, very beautifully made, and we'll be using this to make the right hand of the keyboard today. So this is a blank PCB, so I'll be doing some stuff on this first, right? So step 1 is to use these sockets to basically make hot swap Pro Micro placements. Okay, I have already one out, I don't need another one. So Zorboid, how are you doing? Is my voice loud enough today? So I'm just counting and cutting it. Okay, that might be a problem with that. Oh no, we're right. Okay. So this is 1 and I need another 12. I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here. So that should be good. Yep. Different setup as in, yeah, I've had the new lights. Earlier lights was an issue, so I've bought new lights. My friend told me that for a lot of for my friend and others the voice was very low, so I have tweaked the microphone settings a bit. So hopefully you should be able to hear me a lot better. Yeah, Zorbert, there will be some delay, like always. This is live. So I'll be reading your chats instantly, but you'll be hearing my response a little bit late. So as shown in previous videos, I'm just applying flux and I have my iron slightly off the video. I'll be needing this now. It's getting stuck. Yeah, so starting with the Pro Micro sockets. There's something not right about it today. It's not going through completely, is it? Okay, now it's through. So whenever you are soldering the sockets, make sure you apply enough pressure that it is straightened out. Right. And do it only with both the sockets installed. Otherwise it will be not very even. I'm just reflowing the solder a bit. I'm pressing firmly down at the middle of the Pro Micro, right, so that it takes even pressure. So basically I'm trying to even out the sockets as much as possible, and I'm doing the 4 corner legs first. This will give me an edge so that I don't have to worry about placement in the next setup when I'm doing rest all legs. Oh, okay, it's more than before. Let me see if there is something I can do about the delay. Let me see if I can make it. No, I cannot do anything for the delay today. But anyways, we will go forward like this. So the interesting thing is, I was just experimenting with acrylic for a different thing, and I thought, why can't we make acrylic case for this keyboard, and it worked out pretty well. I mean, initially there was an issue finding a good laser service provider. Now I found it, and they have really nice service. I'll show it to you in a bit. They give very clean cuts in the laser. So if you are in Bangalore, check out Workbench Projects. They have a very nice laser now. Very sharp. Unfortunately, I have only one angle for the camera. I don't have that kind of budget, so can't give you the same experience like Anthony from 001 Keyboards. So want to check this one a bit. Palm Polyga placer. I've never moved out of Bangalore. I have been in Bangalore for quite some time, Zorboid. I have never moved out. So I have to basically reflow it a bit on this one. Yeah, here we go. We have sockets installed. Look at them. I won't walk a level. Get good. Well, I know how good I am. I'll stay in my area of expertise. I don't want to oversell anything. Anthony is good enough for me. I'm happy with that. No, I didn't go anywhere. I was in Bangalore, Zorboid, for the entire this pandemic situation, not going anywhere. Hopefully everyone is safe, man. Things are wild outside these days. So I'll take some diode legs and try to bend them a bunch at a time. I thought you got stuck at your native. No. Okay, I've read that already. So I have my entire setup here in Bangalore alone. I'm not going anywhere. I don't need to go anywhere. So yeah, not going anywhere in near future at least. But never say never, right? That's the saying. You don't know what's hit, hitting you in a couple of days. Life is thus. Oh, okay. Didn't go in well enough. Yeah, there we go. So matching the lines on both the PCB and the diode, I am making sure we have correct orientation of the diodes. Just making sure, yeah, this is good, this is good. What about you, Zorboid? How are you doing these days? What's going on? So we have 2 people in chat. What are you guys up to? How are you dealing with this COVID situation in current times? So at the back side, I am basically bending the diode legs to make sure when I flip it for soldering, it doesn't move. I'll just show you this in a bit. Like this. So I do this so that when I'm holding it, it's not going anywhere. So when even if how much I shake, it's not going to go anywhere. Learning stuff now, designing a plate, 75% is centering. PCB, not plate. Oh, okay. I think AIO3's guide is pretty nice and very up to date on how to design a PCB. I think what you can experiment with is different microcomputers, the MCUs, microcontrollers. So basically, AIO3, if I remember correctly, uses Atmega 32U4. That is in itself good enough for a 75%. But if you want to go larger, let's say TKL or a full size, that is nowhere near big enough, right? So you can think about that aspect of the keyboard as well. Just a food for thought. So that will basically give you a heads up that what you need for other Pro Micros, uh, you know, basically. So like not so 8 mega 32U4 needs an external crystal for clock. Not every one of them needs that. So experimenting with microcontrollers will give you some ideas which will which will be helpful for you. Also make sure you are checking availability of the MCU in India. Not all of them are readily available in India. Atmega 32U4 is, but the Atmega USB 128 is not. So just remember that. Okay. Okay, I'll just bend some more legs before I fix other diodes. Getting into reading data sheets, yes, that should be the way forward. I mean, it's very interesting. I mean, if you take a closer look at the data sheets, you will get to know that small versions, small variations in the product name can have a big impact, especially if they indicate the address lines or some other aspects. So, what PCB house you are planning to use for your PCB? So, just to coming back. I need 1, 2, 3, 1, 2, 4, 5, 6, 7, 8 and 9. I need 9 more. 4, 5, 6, 7, 8, 9. Yes, PCB house for fabricating it. Yes. What are you planning to use? So, I would suggest try local shops, as in where in which city you are. There should be some PCB houses for prototype. Go to them. They should be doing low volume turnkey based approach. You might save some money doing that. And otherwise, of course, you have LAN circuits that are good enough for keyboard PCBs. I am just getting familiar with the keycard and other design elements, getting into routing. Haven't we all done that, skimming through engineering? I did, I can say proudly. We have all diodes in. Right, now let's start soldering the diodes. Okay, this one needs a little bit of fixing and persuasion. Okay, okay, okay. Yeah. And now we can start soldering the diodes. Again, I'll solder one side of diode and then come to the next later on. Okay, forgot about flux, adding flux. So how's your experience so far in designing the PCB, Zorboid? I realize I need to get some music for the next stream so that when I am focusing on it, you don't have to listen to the silence. Routing is little. So there is a auto router that you can try. There are free auto routings. So if you Google KiCad free auto route, you should get some utilities that will help you in auto routing. Especially they come in handy when it's a very complex connectivity. So just Google free auto route, free routing or free auto route, something like that for KiCad. You should get some good utilities to auto route your PCBs. They come in real handy. But don't expect them to make beautiful routes. They are pretty ugly. If you want to do beautiful routes, you have to do it your own manually. Okay, I need to fix two diodes that have moved slightly. This one is done. Yeah, both done. So back to diode fixing. Yeah. Also, there is a KiCad. So let me remember what was it. So there is a utility in Python which can do everything automated. But your keyboard should be designed using certain layouts, as in it should be done. Give me a minute, let me try it, let me search it, give me a minute, I have it. So it's called free route for, and it is there on, 1 minute. So follow this guide which I am posting now on chat. This should save you a lot of time. Back to PCB soldering. So Mr. Keebs or F. Corey does a lot of design and a lot of stream. If you want, you can check out his Discord. I'll link the Discord in a bit. So he has updated it recently with some more information. And if you are on his Discord, there is a guy who has created a auto place and auto route tool utility that should help you out in placing the components that the way you like. I mean, if you are already into understanding KiCad, yeah, I mean, if you want to do that, yes, it's a good idea. But I think those tools also will help you understand quite a bit. I do not use them for complete automation, I don't do that. However, they help a lot in designing the circuit. His tool does a lot of work that, even though we know basic, is time consuming. I mean, it's basic stuff like creating the matrix, it's basic stuff. and even if you know how it is done, there is no way to do it easily. So, I use Mr. Keep's tool to mainly get the matrix part of things done, and then I do everything else, the placing the components and routing manually. I only use auto routing just to give me an idea how it can be done, as in so if you want to learn why diodes are important and matrix, I suggest doing a hand wire build instead, if that is the purpose, because PCB design is more about layouts and traces rather than understanding matrix and diodes. For that, hand wire is a better guide. So, yeah, resistors do not have polarity, diodes do. So, anything that does not have polarity, positive, negative, does not matter. That is correct, yes. Just checking now. I am mostly done with diode. I am just checking if anything is left in diodes. Seems to be good. Seems to be perfect. Yeah, we are done on the diodes. So, let's clip them up. So, if you are already done with hand wire, then yeah, you can go to automated tools. Where is my flush cutter? Okay. Not about polarity. I assume the only way to limit the current at the rate I was at resistor before LED. Forgot there is a thing called Kirchhoff law. Okay. So, LEDs are not my thing. I don't focus on LEDs, to be honest. I think there are a few more things that come into picture. Apart from current limit, the current draw is also important. So, I leave LEDs to the big boys. Also, it depends on what kind of LED you are using. So, even when ARGB, there are variants that have inbuilt controllers, that have controllers that are not there. So, sometimes you need additional chip to control the LEDs. So, not my area of interest, so I didn't bothered about studying LEDs. So I was reading about, because many people asked about ARGB in their, RGB in their keyboards. I studied and I found that per key RGB is a headache from circuitry point of view. So I just didn't bother about it, because you have to think about current draw and how much current can your PCB take, how much current your MCU can take. A lot of things come into picture with that. And if you are doing RGB or any kind of LED, don't forget to put a fuse in your circuit, because if there is any issue in the LED or the PCB itself, the current draw will be very high and there is a chance that it could fry your USB on motherboard, also motherboard of the desktop or your laptop. Static LEDs, you mean? Yeah. I think even in them there is the concept of PWM to basically give the breathing effect. That also requires a bit more understanding than just putting them in series. So now what I am doing, I am just checking does any. So when I soldered, I kept so I soldered all the joints from this side, right? So if you can see here, now I am just checking on the other side, is the flow enough. So here I can say this one is good enough, this one is good enough, this one is not. So I'll try to solder this one. Okay. So I'll just put solder wherever required. I'm just making sure the diode leg is not exposed on the other side. That's what I'm doing. Nothing more than that. It doesn't have any benefit, it is just that I'm making sure the connection will last longer. And okay, this one, is it not soldered from the other side? Let me check. It is now. Okay, I missed one solder joint. Now it's done. So it pays to be checking correctly. 1, 2, 3, multiple checks. Yeah, it's done. Now how do we solder the switches? I'll give you my strategy. Sorry for that. Sorry for that noise. I hope I didn't damage your ears on that. Guys, I'll be back in 2 minutes. I'll switch to stay tuned. I'm not going anywhere. I just need to prepare something. Yeah. So sorry, I switched on a little bit early than I intended to. I need to find these tabs. I didn't remember I had to redo those tabs on this one. 1 minute, guys. I'll just need to find my Allen key. I hope this is the correct one. Yeah, it is. So what I'm doing is I'm undoing these tabs from the previous PCB. Why am I doing it? Because there is a problem with this PCB. I'll just show you in a minute. Why can't they just use Phillips head? Why they had to use Allen screw, man? At least they have provided an Allen key with one set at least. It's not there with all of them. So I was doing some experiment with this PCB and while recording the firmware, the TRRS jack got snapped and it pulled some pads with it. So it's kind of useless on this side. I'll make it work, but I'll have to do some patching on the TRS jack side. So that's the story with that PCB. So let's install the let's install the stabs. Yeah. Okay, I need to clean this side of PCB once before I continue, otherwise it'll be too late for that. Old trusty isopropyl alcohol. So I have not installed the TRRS jack. I'll be doing it after, or maybe I'll do it now. Not a problem. Right, I do have TRS jack here. When do you decide when to flip the stabs hole on PCB? So the main reason one would want to do is when the case is being designed. So if so, I'll just show you an example in a bit. Just give me a minute. I'll have to switch to my screen to show you what I mean by case design. So the big hole is the one that should not be on the PCB edge. and when you are doing the case, you have some tolerances, some not tolerances, but some calculations to remember about. I will talk about that just in a bit. So basically, if the PCB is no, not PCB, the case is having issues with the stab, I will flip it. So I only flip the space bar, and if I'm doing a full size, then the uh, num plus and the what else, enter key on the numpad, those I'll flip to make sure the larger square are on the opposite side of the PCB edge. What that will allow is a tighter case with less worry about the holes and the edge of the diode, not diode, the stabilizer. So what does that all mean? I do not have a PCB to show that, so I'll move to screen capture. Just give me a minute. I'll just show. I'm just loading up my Fusion 360. So just give me a minute on that. Can you see this Fusion 360 Zorboid? Because in OBS I cannot see that. Not yet. Why it's showing blank? No, it's already done. It's open for last 2 minutes. Let me try to capture. So can you see now, Zorboid? So why do we need this? Now this line which I've highlighted is the PCB line, right? The hole will be slightly above this, the smaller one. If we did not rotate it, the bigger hole would exceed this by a few millimeters. So there will be an ugly catch on the PCB, and the stab will not fit the case. You will have to make sure some leverage is given to allow that. If I try it, I'm not sure if I can rotate this right now. I don't want to rotate it, it will otherwise become a mess to clean it up. By the way, what is this? What am I showing you? I'm just showing you a sneak peek on a case that I am working on. Don't tell anybody about it. This is a stream exclusive. So basically, if I don't rotate it, the case will have extra edge cuts that are required to allow for the PCB and the diodes, not diodes again, I'm saying diode again, the stabs to sit in properly. Otherwise, it won't be possible. Just that. Why not extend by a few mils? You could do that, but then the symmetry, everything is around the size of a keycap, which is 19.05. So getting mathematical calculation on a known size are easy. But if you go ahead and add your own sizes, there are chances that you might be off and the final product will not be good. I mean, the size and the tolerance will not be good on that. So basically each keycap is 19.05 mm, and if you keep it that much, your calculation on the PCB area and other stuff will be accurate. Easy and quick calculations, basically. That's what it allows. I'll show one more place where you might want to rotate your stabs just a bit. We'll see one problem that might occur. And this will happen especially when you are doing a lot of layouts in one PCB. And why they don't make everything magnetic? It's so easy to do it when it's magnetic. Also, the case I showed, the PCB for that is currently being discussed, and it will be a completely assembled PCB. You just need to solder switches on that and provide your stabs. Diodes and microcontroller and USB will already be soldered onto it. what are the timelines you have in mind? So I am waiting for some components to arrive, which I have to provide to the PCB manufacturer. Their own cost was quite high for those components, so I had to source a reasonable provider. The TKL-ish, not TKL, it's a full size 1800 layout. Acrylic kit would be around 12,000 for everything. You have to just put on switches and solder the switches in place. That's the main requirement of that. Timelines should be somewhere in September, sometime in September. So see how close the stabs are. If this stab was directly under it, it wouldn't fit because of the tolerances. So I would have, in that scenario, you need to rotate the stabs. Right now, the clearances are good enough. I don't have to worry about it. So yeah, good enough for now. But preparing for these stuff helps you a lot when designing the PCB. So take your measurements properly. Also, whenever you are designing a case, give at least half a mm give for every component, because tolerances are not always what the provider tells you about. So that can get easily messed up. So I hope, Zorbad, you know why you want to rotate stabs now. Just checking none of the stab is loose. Right. Now placing the switches and soldering them. So what I'm doing, these are not the real switches that will go in. This is used to position the plate and the PCB properly. So these are 5-pin switches. They have these extra 2 prongs that protrude through the PCB and will keep it in place. I'm able to show that. Somewhere here. Yeah, those 2 black legs because of that. Okay, Zorboid, thanks for joining the stream. I'll just place them randomly, but try to cover as many places as possible. How longer will you? I don't know. I'll do this and do a complete build of this half, and then I'll close. Maybe an hour and a half, maybe. So now once I have these 5 leg pieces, just want to make sure I am pressing enough. So now I can hold by acrylic, it's not going to go anywhere. The PCB is being held slightly by the legs. It's kind of a friction joint that has been created there. Now I will put in some switches. I won't put anyone on the stabs now, I will need keycaps for that. You have to be careful because acrylic will try to move down. So when I'm putting the switch in, I'm holding the acrylic, not the PCB. I'm leveraging against the acrylic because PCB should not be moving. And you should have, so these are 3 mm acrylic, so there should be some gap. One minute, let me turn the light slightly less. So there should be some gap between the acrylic and the PCB. Almost killed the switch. Yeah, now I'll press the switches and PCB a bit so that they're all fully in without any loose switch. Just tinning a bit and we can start. Now I have black and white switches. I only want to solder the white ones because black ones are just for placeholder and keeping the PCB together. Keeping that in mind, I'll start soldering. So I've just put in the switches and soldered one leg of them. So we have semi-permanent PCB. Now PCB will not move anywhere. I think it would have been better I have put in all the switches in acrylic and then sort of put the PCB on. That would have saved me a lot of time. Just putting in switches as much as I can. Switches need a little bit of persuasion because the plate is quite well made and has very accurate tolerance on it. Right, now let's get on with soldering other switches that are left. Whew. I am only soldering one leg now because I will be putting some pressure from the other side so that they are seated properly. So I'm just doing one leg right now. And done on the switch that I've added. That was quick. So I'm pressing the switch as hard as I can between my index finger and my thumb, and I'm just reflowing the solder. This will make sure any gap is not left between PCB and the acrylic. Sorry, PCB and the switch. There should be some gap between the plate and the switch and the PCB. Now I can remove the black switch and put in the white ones. Do we have anyone in chat? Hey Nemo. So this is the clear acrylic case. So this is what I posted about group. This is what everybody will be getting. And man, these have come out beautiful. I'll just show you one very good thing. So look at this, the edge, smooth edges, man, I love this. Right, now let's put in the switch, the new ones. Again, I'm just doing a temporary solder with one leg so that I can leverage some force to put it in place properly. I'm just checking if any switch needs a bit more solder. This one does. So these black switches are functional. These are OG cherry blacks. I got them as a sample from one of the Indian suppliers, right? So just using them for helping me solder. Now about time we do the most difficult switches. So stabs switches are cut out large. They do not have the same. One minute, let me just get some more things to help me with the soldering. Just a minute. So basically I'll be using the 2U caps or the caps around them to position. This is something Anthony from 001 keyboard came up with, or at least that's where I saw it. And I'll be just doing what he did. I'm just turning off my solder for a bit. So I'm just putting random switches. I don't specifically need this. Just putting random switches. So I've put the switch on the longer keycaps and I'll put them on the stab at the same time. So basically it is now held by the stabs and the longer keycaps, so it won't move. It will have a lot lesser room to move. Why doesn't it fit? And switches are in, they are held by stabilizers, so they won't move. Now I can go ahead and solder them. This is the same strategy you should use to solder your switches in. Now I'll do the same. I'm pressing from both sides on the PCB and the keycap just to reflow the solder, and so that there is minimum gap. So this control keycap is not the correct one, just it's a placeholder to see how the alignment is, and I see it's quite straight enough, so not an issue. I will get a numlock 2U keycap on this, or the enter rather, which is available here. So numlock is on the other PCB, I guess. Not numlock, the plus key. Okay, this switch goes in like this, so it will be sitting like this. Again, the same drill. Just soldering one side. I'll just inspect it once more and then I'll get into soldering. This one is not sitting properly. Now taking off the keycaps and doing a permanent soldering job. It's not coming out like this. So why I removed all the keycaps? Because now I have a even surface to do the rest of soldering. So one very important thing while soldering, you will sweat a lot, so drink as much as water as possible. I'll just take some now. It's very important to keep yourself hydrated. And we are officially done soldering the keyboard. Just taking a second look at all the joints. Yep, done. So now I already have the Pro Micros prepared for this. This was done in the previous streams, so the only thing to make sure is the right orientation. So, okay, 1 minute. So the top right, this one is the raw. Your PCBs will say raw on one side. This pin should align with it, right? Make sure you are doing it the correct way. So on this PCB, the raw is on top left. Come on, focus. Here. So I'll have to invert it and put this Pro Micro in. Like so. Ta-da! Time for assembling the case. So I'll show all the separate layers that are going to be provided with the case. So there is one obvious switch plate, then there is one which is closed on both the TRS and the USB side. One that is completely open, that comes with another part. There will be a middle, I'll come to it once we are installing it. So I'm just trying to see where I can peel this off from. Peeling is very important. And voila. Sorry guys. So each case will have 7 layers, and both left and right will have slightly different orientation of each layer. I mean, bottom and top will be the same, but rest all can move a little bit up and down. Peeling is very, so I don't keep nails, so it's very hard to start the peel. Come on. So peel itself is very satisfying, but starting it is, especially when you don't have nail, is very headache. It's a big headache. this will interfere, so I'll need one more of this. So this is the version 1. I am going to modify the case slightly a bit because, okay, 1 minute, let me complete it and then we'll talk. हो जाए यार. So I need 3 of the smaller pieces. So to allow for the PCB, this piece are held just by the screw provided. So you have to be very careful when you are installing them. I will talk about installing and how to put it together in just a minute. And then we have the back. So before I put this in, I will bring in the mounting hardware. Okay, I have to, where have I kept it? Yep, here they are. So these are interlinking screws. One. Okay, I am not putting one layer, so I forgot about one more layer. Oh, okay, this is okay. Let's do it from the other way. I'll do it from this side. That will be easy. So I'll place 1, 2, 3 and 4 to kind of make a template for every piece to fit in. This is going to be a bit tricky to get it right. Finally. Zorbert, are you back on chat? I guess not. So once this screws is in, we can pretty much be able to remove the so when you are putting in screws, you can put some from top and some from bottom. So this will give you a bit of help when you are assembling or disassembling the case in future. Otherwise everything will just keep falling. Here's our board. This is how the complete keyboard looks like. Now you'll need Phillips head screwdriver to basically tighten the screws. Okay, I have one left. So when I'm turning, I will make sure I don't forget about the ones without. So basically these screws I might have to change because I'm not happy how they are behaving, because some of them are fitting perfectly fine, some of them are larger than the length I ordered of 2 mm, sorry not 2 mm, 20 mm. So, but you will get those screws which fit properly, or I'll increase one of the layer height slightly to compensate for it. So hex screws, so I'll be providing you these screws, so you don't need to run around for hex until and unless there is a very specific need for you to use hex. This should be better. And frosted acrylic, I tried inquiring, it is not available, at least with the vendor I was working with. Now this is already pre-flashed, but it will read as a write keyboard because that's how firmware is set up. I'll open switch hitter. And let's test the keyboard. Okay, so you cannot see. 1 minute. Let me add switch hitter on the screen. Yeah, not this way, sorry. So I have not done this before. Let me try to do it again. Why is it not coming? Okay, let me try something. Remove this in the new scene. Where is this switch hitter not showing up? Yeah, perfect. Now I'll add camera. Success. Now we have a working keyboard. So don't worry, it is reading it as right, therefore, sorry, it is reading it as left, therefore it is working like that. Once I attach it to the other half, it will start working properly. Let me do that. Let me get rid of some excess. So this is the left hand. Where are that? Okay, I'll use this one. I cannot find the TRS cable that will be part of. I'm not sure if this will fit. No, it doesn't fit. I have to find 1 minute. I hadn't switched to. So basically this is the TRRS cable you will be getting. A beautiful blue braided TRRS cable. Uh-oh, we have a disaster on stream. Not again. Okay, so the TRS cable has okay, so now yep, it happened again. It was not soldered properly. Let me do it again. I hope it didn't lift any pads. So that's how you know nothing is pre-recorded in this stream. Now you know. Okay, I think I didn't solder it properly, therefore it came out. Because I can see only one leg having solder, the others are blank. Easy fix, it remains to be seen. I have to open the PCB. Once I see the PCB, I should be able to tell whether it's an easy fix or it's a waste. I should have listened to my own advice and put some glue to avoid that from happening. I want to do those in the last. I should have known when everything was going so smooth that something's gonna break. Moment of truth is coming. I hope it is just a simple fix, and phew, it should be easy enough to fix. I am somewhat relieved. Okay, let me get some glue. I won't leave it to chance this time. I'll be back, guys. I am back, and we are going to use the best fix very quick. So don't try this at home. Well, unless you know what you're doing. So I have done what was possible for me. I just hope it works. I use toothpick. Toothpick for what, man? Zod, what can you please elaborate? What do you mean by I use toothpick? And just to be sure, I will put some more Fevikwik around the edge. No, it's not getting anywhere. Ah, okay. No, I'm not a pro. No, not a pro. And before I do anything, I'll just pop it in and switch to here just to see. Successful! Operation was successful, guys. Let me just put it together. But now I will do one modification in the future version of this keyboard. Fortunately or unfortunately, the OG guys will get SMD version only. The fix is quite easy. Oh my god, I'm not talking on the mic. You guys didn't tell me you were not able to hear me. My mic was way far away from me. My light might be about to die, so you might get some darkness. Okay, let me put in the keycaps now. Whew. And this is pretty much complete. Alright guys, so we are done with the stream. I'll close the stream now. Have a nice day. Bye bye.